Good day everyone, my name is Asya and today I will be presenting my assignment titled Application of MOSFET in Dosimeter. So, what actually is a MOSFET? MOSFET stands for Metal Oxide Field Effect Transistor. MOSFET is a three-terminal device with source, base, and drain terminals. It is a subclassification of the field effect transistor. The MOSFET is classified into two types based on the type of operations, namely enhancement mode MOSFET and depletion mode MOSFET. MOSFETs may be either P-channel or N-channel, but P-channel MOSFETs are the most common in dosimeters. The primary use of MOSFET is to control conductivity, or how much electricity can flow between its source and drain terminals based on the amount of voltage applied to its gate terminal. Now, I will talk about how P-channel MOSFET operate. A MOSFET can be thought as a voltage-controlled solid-state switch. When the voltage applied to the gate is too low, the region between the drain and the source contains an excess of electric charge which prevents current flow. When a negative voltage in excess of the threshold voltage is applied to the gate, these electrons are repelled and an inversion layer, sometimes called the channel, forms. This inversion layer allows the current to pass from drain to source. Moving on to the next part is about dosimeter. A radiation dosimeter is a device that measures dose uptake of external ionizing radiation. It is worn by the person being monitored and is a record of radiation dose received during radiotherapy, brachytherapy, and radiology applications. MOSFET transistor dosimeters are now widely used as clinical dosimeters for radiotherapy radiation beams. The gate oxide of MOSFET, which is silicon dioxide, is an active sensing material in MOSFET dosimeters. Radiation creates defects in oxide, which in turn affects the threshold voltage of the MOSFET. I will now talk about how MOSFET works in the dosimeter. MOSFET determines dose through measurement in change of threshold voltage. Firstly, as a MOSFET is irradiated, electron hole pairs are created in the silicon dioxide. Then, holes migrate to the interface between the silicon dioxide and the N-type substrate. Next, the increase in holes in the interface region retard the electric field induced by applying the negative voltage to the gate. This means that a greater voltage must be applied to the gate to induce current flow between the source and the drain. Change in threshold voltage is proportional to the change in number of thread holes and thus to the absorbed dose. I will now briefly talk about the benefits of using MOSFET in dosimeter. Firstly, the MOSFET dosimeter is direct reading with a very thin active area which is less than 2 micrometer. Second, the physical size of the MOSFET when packaged is less than 4 mm. Third, the post-radiation signal is permanently stored and is dose rate independent. These are the references that I used for the assignment. That is all from me. Thank you.